a look at a few more questions. So number 5, 30h cubed plus 35h squared minus 25h. So start by trying to pull out a greatest common factor, and it looks like we can pull out a 5 from each of these. These numbers are each divisible by 5. We can also pull out an h because each of these terms has at least one h in it. So pull out a 5h. All those terms have that in common. So you can fit 5 into 30 6 times. So we have 6h squared left there. We can fit 5 into 35 7 times, leaving us with 7h. And we can fit 5 into 25 5 times, leaving us with 5. So if I distribute this 5h back in, I get 30h cubed plus 35h squared minus 25h. So how many terms do we have? We've got 3 terms. It doesn't look like I can pull out any more numbers or letters from here. We have a trinomial where the first coefficient is not 1. So we have to either do trial and error or the x factor method. So I'll do a demonstration of the x factor method here. First, just draw a big X. And a little star there, and an add sign there. So first thing we do is multiply the first and third, including the sign. So 6 times negative 5 gives negative 30. We put that result up in the top of the X. And then next thing we do is take the middle term, including the sign, and we drop it below in that part of the X. So now at this stage, we want to find 2 numbers that will multiply to give negative 30 and add to give positive 7. So we can start by listing factors of 30. We've got 1 and 30. We can do 2 and 15. We can do 3 and 10. What else can we do? We can do 5 and 6. But if we look at 3 and 10, if I went with positive 10 and minus 3, that would multiply to give negative 30, and 10 minus 3 is positive 7. So I should choose positive 10 and minus 3 for my factors. So I put those numbers here, and then the next thing I want to do is divide by the number attached to the first, the squared term. So I divide each of these by 6. Now the next thing you need to do is reduce these 2 fractions. So you can do that by, just pencil and paper, or you can use your calculator at this point. So if you want to reduce 3 over 6, you do 3 divided by 6. So that gives you 0.5, and if you want that in a fraction form, you hit math, and then just hit enter on fraction, and then that just gives you the reduced fraction. Same thing with 10 over 6. If you want to reduce that, 10 divided by 6, that gives you that number, and if you want it reduced, you just hit fraction, hit enter, 5 over 3. So this is 5 over 3. And this is minus 1 over 2. So these 2 fractions will give you what your factors will be, what you'll end up with. So this whole thing over here was so that we could factor this part of our question. So this minus 1 over 2 means our factor will be 2h minus 1. And then this 5 over 3 means our factor will give 3h plus 5. Right, for the next question, we've got 18m to the fourth m squared minus 4. So you would try to pull out a greatest common factor first. Doesn't look like we can pull out any numbers from all three of these terms, nor can we pull out any letters, so no, we can't do a greatest common factor at this point. We've got a three-term polynomial where a is not 1. It doesn't look like it's a perfect square. Something times itself can't give 18, and something times itself can't give 4, at least not whole numbers. So we can do, again, the X factor method. So we'll just use this base down here. We do this term times that term, including the sign. So 18 times negative 4 gives us negative 72. So I write that number here. And then again, I take this number, so it's a positive 1, and I write it in the bottom of the X. So I look for two numbers that will multiply to give negative 72 and add to give 1. So I can start by listing factors of 72. Factors of 72, 1 and 72. 72 divided by 2 gives 36. 72 divided by 3 gives 24. 72 divided by 4 gives 18. 72 divided by 5 doesn't really work. 72 divided by 6 is 12. 72 divided by 8, so I skip 7, is 9. So if we look at this, we could arrange for 8 and 9 to add to give positive 1 and multiply to give negative 72. So if I chose positive 9 and negative 8, positive 9 minus 8 is positive 1, and negative 8 times positive 9 is 72. So those are my two numbers that I write here and here, negative 8 and positive 9. Now I divide by this number in front here, the x squared term. In this case, it's the m to the fourth term. So I divide this by 18, and I divide this by 18 as well. This will give negative 4 over 9, and this will give 1/2. So these two fractions here and here will give me my factors for this question. So factors will be two binomials. So this term, I take this 9 and put it in the front of the first one. It will go with a variable m squared because I want it to make m to the fourth. And then this negative 4 goes in the back end of that first binomial. This one will give me 2m squared, and then the 1 goes in the back end along with the sign. So finally I've got 9m squared times 2m squared, which is 18m to the fourth. So just to check, 9m squared times 2m squared gives 18m to the fourth. 9m squared times 1 is positive 9m squared. Negative 4 times 2 is negative 8m squared. Negative 4 times positive 1 is negative 4. So these will combine to give 18m to the fourth. 9 minus 8 is positive m squared, and then minus 4. So this works, and these are my factors. Next question. 3x squared minus 2xy plus 15x minus 10y. You would try to pull out a greatest common factor. It doesn't look like we can. If I tried to pull out a 2, this would give a fraction. This would give a fraction. That would be fine. If I tried to pull out a 3, I'd get a fraction out of there, and a fraction out of there as well. So that's no good. If I tried to pull out an x from all of these terms, this one wouldn't allow me to take an x. I'd have, anyway, can't take out an x. If I tried to pull out a y, neither of these ones have y's in them. So no GCF at this point. So we've got a 4-term polynomial. There's no simplifications at this point I can make. X squared is the only x squared term. There's only one x term. There's only one xy and only one y term. If I were to, say if I had a positive 2y at this point, I could combine these two, but I don't. So what we want to do is just pair some terms together. Try pairing these two. So for the first two terms, I can pull out an x, just an x term. I can't pull out a y, so I'm left with 3x minus 2y. So if I distribute this x back, I get 3x squared minus 2xy. So that's good. And from the last pair, the second pair, looks like I can pull out a 5. And it doesn't look like I can pull out any letters because they don't have anything in common there. So if I pull out a 5, I get 3x and then minus 2y. So if I distribute this 5 back in, I get 5 times 3 is 15x. 5 times negative 2 is negative 10y. So that's good. And now at this point I have a 3x minus 2y in each of these terms. So I pull out a 3x minus 2y because they have that in common. And then I'm left with x plus 5. And from here it doesn't look like I can go any further. I don't have a difference of squares scenario happening at this point. So looks like we're done. Next example. Another 4-term polynomial. Doesn't look like we can combine any terms. So I can pull out a 2, leaving me with negative 12y squared plus 3y plus x minus 4xy. Next thing we want to do is just group pairs of terms and see if we can pull out a greatest common factor from those groups. So I try those two pairs. From the first two, I can pull out a 3y, and then that leaves me with, so negative 4y plus 1. And then from the last two, I can pull out just an x. So that leaves me with 1 minus 4y. So if I distribute this x back in, I get x and minus 4xy. And same here, if I distribute the 3y back in, I get negative 12y squared plus 3y. And then this 2 comes along for the ride as well. So at this point we have a 1 minus 4y here and a 1 minus 4y here. So I can pull this term out from both of these. So what does that look like? We've got 1 minus 4y and 3y plus x remains. That's about as simple as you can get. I believe in the answer key they had this written as 2 minus 8y, but if we can pull out a 2 there, this is fine as well.